of ultracapacitors product training module. This presentation will provide an overview of the applications for the K2 cell series and discuss the specifications, usage, and part number breakdown. Ultracapacitors are used in the following types of applications. Peak power. The excellent power performance and cycle life of ultracapacitors provide pulses of power where the primary power source cannot. This allows power supplies, generators, and batteries to be downsized and/or have a longer life when used for the baseline power requirement. Depending upon the duty cycle of the pulse requirements, this can be referenced as either a cycling application or a DC life application. Secondly, the backup power. The long calendar life of ultracapacitors allows them to be used as a backup power source. In this application, the ultracapacitors are constantly charged and utilized when the primary power is lost. They can be used for short-term power to gracefully shut down a system or as a bridge power to a fuel cell or generator. This would typically be a DC life application. The third application model for ultracaps is regenerative energy. The high efficiency and high charge-discharge cycle life of ultracapacitors makes them ideally suited to capture pulses of energy and reuse this energy. Energy reuse savings effectively reduces fuel costs and reduces air pollution. Maxwell's K2 series of ultracapacitor cells are ideal as a building block for many different applications: wind turbine pitch control, bus, truck, and locomotive starting, and many other applications requiring a pulse of energy that cannot be efficiently provided by a battery or power supply alone. They have become the industry standard for high-power, high-energy applications. In many cases, they work in tandem with batteries for applications that require both a constant low-power discharge for continual function and a pulse power for peak loads. In these applications, the device relieves batteries of peak power functions, resulting in an extension of battery life and a reduction of overall battery size, cost, and weight. The K2 cell is also an ideal source of backup power. It can provide extended power availability, allowing critical information and/or motor functions to remain available during dips, sags, and outages. Additionally, like all of Maxwell's ultracapacitor products, the K2 cell is capable of accepting charges at the identical rate of discharge. The K2 cell series comes in 5 capacitance values from 650 farad to 3000 farad, with each one available in either weldable terminals or thread terminals to allow process and performance optimization. It can be convenient to perform proof of concept work with threaded versions and use the weldable version for prototype and production purposes. All versions have the same diameter and only change in height based on the value of capacitance. Typical applications include hybrid diesel-electric buses, industrial backup power, telecommunications, mining and construction equipment, trains, trams, subway trolleys, grid stabilization, and utility vehicles. Shown here are the specifications that will help the customer to evaluate if it meets the design requirements. Some important specifications include the following. All cells can operate up to 65 degrees Celsius and down to -40 degrees Celsius. The 3000 farad version is the most popular cell and can sustain 130 amps to 210 amps of continuous charge-discharge. Cells have very low leakage currents and low resistance. Shown here is the continuation of the specs for mechanical features, monitoring, and power and energy calculations. If the customer wants to learn in detail about how these specifications are measured or calculated, please refer to the Maxwell datasheets. For a systems design, it is important to take the end-of-life criteria into consideration for system performance over time. The end-of-life, EOL, is determined by a decrease in capacitance and an increase in ESR. End-of-life becomes a defined point, not an actual failure. Maxwell defines EOL when one of two things happens: a decrease in capacitance below 80% of rated value or an increase in ESR to... In summary, Maxwell's K2 cells' key features are over 1 million charge-discharge cycles, greater than 95% efficiency, 10-year-plus life capability, operating temperature -40 degrees to 65 degrees Celsius, and UL, RoHS, and REACH compliance. Some of the key benefits include cost-effective hybrid system design, power design for life of the application, high reliability in mission-critical applications, long life, backup power energy source, and green technology. Ultracapacitors, also known as electric double-layer capacitors, EDLC, or supercapacitors, are alternative energy storage devices which store energy by electrostatically or physically separating positive and negative charges. This is in contrast to batteries which store energy via orbital electron exchange chemically. The lack of chemical reaction permits ultracapacitors to be charged and discharged up to 1 million times, compared to hundreds or thousands of charge-discharge cycles in batteries, and at a faster rate than batteries. In backup power applications, ultracapacitors can have up to a 15-year lifetime and operate over a broad temperature range. Historically, the use of a single energy device to satisfy the entire power specification of an application required designers to either design for power, at times providing excess energy, or design for energy, at times providing inadequate power. By leveraging the unique features of both technologies, customers have more freedom when designing a power system. The high-performance characteristics of Maxwell Technologies ultracapacitors allows one to develop hybrid power system solutions that cost less and perform better than non-hybrid solutions.